So if I put then the sea level curve next to the stratigraphic diagram, then let's just see whether how much do they agree at first order. You can sort of see if I move the shelf break from the left to the right here, and you can sort of at first order you can see again the Jurassic sea level is sort of rising. The shelf break is moving further towards the shore, and then in the Cenozoic time, at the first order at least, sea level is falling, and the shelf break is moving further and further into the sea, into towards the ocean. There's some minor tectonic events happening in the Scotian Basin stratigraphy, so it's not a perfect fit, and nor would we expect it to be. One interesting one to point out is a big impact crater there as well, which obviously disturbs the stratigraphy quite a lot. And there's also some minor plate tectonic reorganizations happening in the North Atlantic, which also have some effect on the stratigraphy here. But anyway, at first order, we see this pattern, it sort of fits. Now, where it gets most interesting is on the second order, where we can really start nailing down source rock seals reservoirs. So these are the second order cycles that I've pointed out before. You see the reservoirs, the timing of those here on the right. So these intervals are of greatest interest to us. And then focusing on the maximum flooding times at these different times, do they match with the stratigraphy? And I'll try to replay it here. Yeah. You can sort of see the early Eocene here matching with this deep water carbonate. You can sort of see the Turonian flooding coinciding with this deep water carbonate and this basically shale incursion. Same for the Intra-Aptian, the Naskapi shale. Same for the Valanginian Hodrivian with the O marker as it's called, also again a deep water carbonate. And then in the upper Jurassic it's a bit less clear, but it seems that the best time for flooding would be in the Kimmeridgian and Oxfordian, which is also the time when the source rock is postulated, although not well proven. So that's the source rock symbol here on the lower right. Then there was this one peak I mentioned earlier, which in the Pliensbachian in the early Jurassic, it might coincide also with the deposition of the Iroquois salt. But this part of the stratigraphy is not well known. There's very few wells that have penetrated this part. And also the basin was actively rifting, so in a way, this can't be proven yet, but it might be another one of those maximum flooding times leading to maximum flooding or early flooding of this basin at that time. Now, can we see this in the seismic? And yes, we can see this actually relatively clearly. This is a clipped seismic section from the literature. And you see these sequence stratigraphic patterns and these facies belts moving up and down along the shelf. So the yellow and orangey parts are basically the shelfal sands. Then you can get in these cliniforms here on the right. So you're going from the top sets here down the shelf onto the slope, and then at some point you enter the basin. And you can basically see this rhythm from a reservoir, then a flooding, a reservoir, a flooding, a reservoir, a flooding, repeating a number of times. And you can correlate then these again to the maximum flooding time. So it's not only within the stratigraphic diagram, you can also relatively clearly recognize them in the stratigraphy, in the seismic as well. So another thing I want to point out, and that is basically a hypothesis at the moment, those key reservoirs here indicated in yellow coincide also with times when I've got this short-term variation as a result of the ice ages coming and going in the Jurassic and Cretaceous. Now the question is, and this is just a sketch, what does this short-term cyclicity really look like? So for example, one of the cycles is 400,000 years, and this is sort of a 400,000 year sketch. So sometimes it hits the maximum of this envelope on either side, sometimes it doesn't. But this is the kind of cyclicity that you would expect during those formations where you have these reservoirs. Now, and that you need to think about the facies belts are moving very rapidly with over the order of tens of thousands of years. And that could then result that there's more sediments moving about all the time. Now, from an oil and gas perspective, then you would expect better reservoir properties, so the sands get well sorted. Now, there's some data that suggests that is the case. And I've seen it also in other basins, also in the North Sea, for example, but it's a little bit too speculative at the moment. But it's something to keep in mind that it may affect the sedimentation of individual sand bodies as well, because of the ice ages going up and down, moving sediments around. Now, going from the shelf into the deep water, and I must say this is a bit hard to see on the screen. You need to have a large printout of a seismic line to see this. You can decipher the patterns here as well. There's a few maximum flooding surfaces that experts can pick out on the seismic lines like this. And I could tie them to the maximum flooding times. Then you can divide them in so-called mega sequences. So you can understand and group the different parts of the stratigraphy here. And the conclusion is basically that the case was Scotian Basin, it does actually behave very well. And the sedimentation, to a large degree, seems to be determined by global mean sea level varying over time.